Hi, I'm Mark Vandenbush. If you found your way to this video presentation, you are likely associated with the Introductory Astronomy class at Michigan Tech. I made this video to meet one of the requirements for that class. This presentation is about the James Webb Space Telescope. The development of the James Webb Space Telescope started back in 1996 and was originally scheduled for launch in 2007, but rising costs and other delays held the project back. Since it is under construction now, what you are looking at is actually an artist's rendering. This image is from the Times News Daily. It's now scheduled for launch in 2018. It's a collaborative effort between three agencies: NASA, the European Space Agency, and the Canadian Space Agency. It is sometimes referred to as a replacement for the Hubble Space Telescope, but there are more differences than similarities, starting with the fact that the Webb is an infrared telescope. According to Ivan Goh, who wrote an article in Universe Today, there are four main objectives for this project. One, to give us a look at the first stars and galaxies to form in the universe over 13 billion years ago. A second objective is to perform a comparative study of the spiral and elliptical galaxies of our age with the faintest, earliest galaxies to form in the universe. Another is to look through the clouds of dust to watch stars and planets being born. And finally, to look at extrasolar planets and their atmospheres, keeping an eye out for biomarkers. To achieve the objectives, it has a 6.5 meter main reflector and associated instruments. The reflector is made up of 18 separate segments that unfold and adjust to shape after the launch. Here is one of those segments being assembled. According to ARS Technica, its primary mirror will be 50 times the area of the Spitzer Space Telescope, and its infrared images will have 8 times the resolution. The Space Telescope Science Institute identifies 4 major instruments aboard the Webb. There's the near-infrared camera, which is the primary imager in the wavelength range of 0.6 to 5 microns. NIRCam is required by many of the core science goals, including the detection of the early phases of star and galaxy formation. There's the mid-infrared instrument, which will provide direct imaging and medium-resolution spectroscopy. MIRI is expected to make important contributions to all 4 of the primary science themes: discovery of first light, assembly of galaxies, how stars and planetary systems form, and the evolution of planetary systems and conditions for life. There's the mid-infrared spectrograph, which is a near-infrared, multi-object dispersive spectrograph capable of simultaneously observing more than 100 sources. The NIRSpec will be the first spectrograph in space that has this capability. Targets in the field of view are normally selected by opening groups of shutters in a micro-shutter array to form multiple apertures. And finally, there is the near-infrared imager and slitless spectrograph. It is expected to contribute to all 4 science themes as well. One of the interesting things about this telescope is that it will not be in orbit around the Earth. It will actually orbit the Sun 1.5 million kilometers away from Earth at what is called the second Lagrange point. And actually what happens, at L2, it will make a slow orbit around L2, while L2 makes an orbit around the Sun. One reason for this orbit is to keep the telescope out of the shadow of the Earth so that it can make observation without interruption. In addition, the orbit around L2 will keep the Earth, Moon, and Sun in the same direction, which will make it possible to shield the telescope from the heat emanating from all 3 bodies. There are a lot of systems and subsystems that are required to keep the Webb Space Telescope functioning. One of those are the sun shields. They keep the infrared light from the Sun, Earth, and Moon, as well as the spacecraft electronics, from reaching Webb's mirrors and science instruments. Here you can see the solar panels that convert sunlight into power needed to operate the science instruments and the spacecraft subsystems. For more information, please see nasa.gov. That concludes this presentation.